Solving two-step equations. Key questions: how do you solve a problem with multiplication and addition? And how do you solve a problem with division and subtraction? So how do you solve problems with two steps? So today we're going to look at how to solve two-step equations. So go ahead and pause the video and copy down the following. So we're still rescuing the variable by using inverse operations like we did with one-step equations. But for two-step equations, you're always going to add or subtract first, and then you're going to multiply or divide. So for the first example, to undo the addition, I'm going to go ahead and subtract 8, which will leave me with negative 4x. The plus 8 and the minus 8 will cancel out. Negative 32 minus 8 is negative 40. And now I have multiplication here, which I'm going to undo using division. So divide both sides by negative 4. Negative 4 divided by negative 4 is 1, so I'm left with 1x. Negative 40 divided by negative 4 is 10. So I've solved my two-step equation using two steps. The next example, to get rid of the subtraction, I'm going to go ahead and add 7. So subtracting 7 and adding 7 would cancel out. I'm left with the x over 2. Negative 19 plus 7 is negative 12. Now to undo that division, I'm going to multiply both sides by 2. So 2 and 2 would cross-reduce. I'm left with 1x. Negative 12 times 2 is negative 24. So for both equations, I added or subtracted first, and then I multiplied it or divided. Go ahead and pause the video and try both examples. In the first example, you should have gotten rid of the subtraction by adding 9. So that's my inverse operation. I'm going to bring down 3x. This equals 0. Now negative 21 plus 9 is negative 12. To get rid of the multiplication, I'm going to use division. That's my inverse operation. 3 over 3 equals 1, so I'm left with 1x. Negative 12 divided by 3 is negative 4. The second example, you should have subtracted 8 to both sides to get rid of the addition. You're left with x over negative 4 is equal to negative 40. Your second step should have been to multiply both sides by negative 4. This gets rid of the division, so this cross reduces to equal 1. So I have 1x. Negative 40 times negative 4 is positive 160. Now, just like the one-step equations, you can always check your answers by just plugging in the x into the original equation. So if I wanted to check my answer, I would take 3 times negative 4 and subtract 9. 3 times negative 4 being negative 12, minus 9. Here's where I slash and dash, and I get negative 21. So my answer checks out. You can do the same thing with the other equation by plugging in the x right here into the equation to see if it equals negative 32. Go ahead and pause the video and try these two examples. Now these are a little tougher because most students right off when they see that subtraction they would think they're adding 4. But if we added 4 plus 4 is 8. And we bring down that minus 2x and this would be 20, which doesn't really help us because we still have a two-step equation. So instead, whenever you see the variable after the subtraction, we're going to go ahead and slash and dash. The reason why I do this is because now I could rewrite this equation. I know that this equation really is negative 2x plus 4 is equal to 16. By doing that, I could see that really, instead of adding 4, I should have been subtracting 4. which leaves me with negative 2x. This would now cancel out to equal 0. 16 minus 4 equals 12. Then my last step, divide by negative 2. This would equal 1x, and this equals negative 6. So if you missed that first problem, go ahead and pause the video, retry the second example. For the second one, again, since the variable's after the subtraction, I'm going to go ahead and slash and dash. If I rewrote this, I could rewrite this as x over negative 7 plus 21 is equal to negative 14. And now I'll do my two steps. So the first step to get rid of the addition is subtract 21. I'm left with x over negative 7 is equal to negative 35. My last step, multiply both sides by negative 7. Cross reduces to equal 1x. And then 35 times 7 to get a positive 245. Here's our last example. A carnival charges $5 for admission and $1.25 per ride. How many rides can you afford if you have $20? First, see if you could write a two-step equation for this problem. So if you did write it, you would have $1.25 per ride plus the $5 admission would equal the $20 that you have to spend. So our first step, subtract 5. Which gives us 15. My last step, divide by $1.25. So this would equal 1R. Now we can always do this on the side here. So 15 divided by 1.25. We know we're going to move the decimal twice. So moving this decimal twice. Add 2 zeros here. Goes in once. And then twice. So my answer, you can ride 12 rides. So looking back at our key questions, how do you solve negative 4x plus 8 equals negative 32? To get rid of the addition, we'd have to subtract 8 from both sides. To get rid of the multiplication, we'd have to divide both sides by negative 4. Again, addition or subtraction first, then the multiplication or division. For the second example, to get rid of the subtraction, you would have to add 8 to both sides. To get rid of the division, we'd have to multiply both sides by negative 4.